So Boost is basically the software that provides onboarding tools and also indices, data, user data, and then pushes it to the Lotus miner to be stored on Filecoin. And I'm going to talk about the features that we introduced in Boost v2. So my name is Anton. I'm a software engineer at Protocol Labs, and I've been part of the Boost project for the past 2 years. So we released Boost version 2 in July of this year, and you can find it on the GitHub repo. It's open source as everything else that Protocol Labs does. And the major feature that we built for Boost v2 was around retrievals. We basically wanted to offer retrieval functionality for SPs so that they can index and store and provide retrievals for large scales of user data. So in this presentation, I'm mostly going to talk about the local index directory, and at the end, I'm going to share how we also think about data within the Boost team and what kind of data integrity you can provide. So first of all, why did we introduce the local index directory, and why is it replacing the DAG store? So the DAG store, for those of you who don't know, is the indexing component that has been used historically in Lotus and later in Boost, which basically handles indexing of user data so that when users push their data to storage providers, they can later retrieve it and have also fine granularity over their data, given that Filecoin stores large sectors. So why did we want to replace it? The quick answer is the DAG store is basically a single process component and doesn't scale well for large amounts of data, and also doesn't provide any high availability or redundancy. So I'm going to quickly recap how data is stored onto the Filecoin network. As you know, the initial data preparation step is to basically build a car file out of the user data. So imagine it if you have a collection of, let's say, photos that you want to publish to Filecoin. You first need to build a car file out of them, which is basically a content addressed archive, which provides a collection to all your files, and then later on you can access the individual files within this archive. So once you have the car file produced, you need to add a bit of padding to it so that you can then generate a Merkle tree. And using the hash of the Merkle tree, you can easily make sure that the data is correct once you've transferred it to DSP, and you can make sure that the storage provider has the exact data that you want to store, and make a deal, make an agreement on that data. On DSP handling side, DSP obviously needs to get the data from the user. That could also be an aggregation service. It needs to compare the compy, the Merkle tree root of the data, to make sure that it's storing the exact data that the user wants. And then this piece is passed on to the Lotus miner for sealing, encoding, so that you know that DSP is storing the number of replicas that you've agreed with, and later on for them to send the proofs to the Filecoin network periodically. So that's basically how data flows into the Filecoin network. So with Boost v2, we basically wanted to provide support. We wanted to provide retrieval functionality for the largest SPs in the network. Currently, this means scale around 50 to 100 petabytes. Of course, this is raw capacity. It's not exactly all filled with data, as you know. So currently, those SPs at max hold probably 10% of data. Even so, we wanted to provide functionality even with the future growth of the network taken into consideration. So coming up with the requirements for that feature basically means, number one, support SPs in the 50 to 100 petabyte raw storage power scale. Second of all, we wanted to make sure that even if this storage is filled with fine-grained index data, for example, 16K blocks, such as Falcon or any other blockchain data, we can index it and provide it for retrieval. We also want to make sure that there are fast indices and CID lookups and fast index ingestion. So the DAX store can do that, but not at this scale. As I mentioned, it's single process and it doesn't scale to multiple machines, making it very difficult to support those requirements. The database that we picked to build an adapter for and provide it to storage providers is YugaByteDB, which itself uses RocksDB, which is very similar to what DAX store was using, which used LevelDB as an engine for the in the context of embedding it within its per node storage engine. So basically, the solution that we're building on is similar to the DAX store, but a further level extrapolated upstream so that it provides high availability and horizontal scaling. So the data store requirements, as I mentioned, from 50 to 100 petabytes. In terms of sectors, this means from between 2 to 3 million 32 gigabyte sectors. If we think of every 32 gig sector consisting of 16K blocks, because the data could be fine-grained, not necessarily, but we want to support that use case. That comes at about 2 million blocks within a sector. So the data store must support up to 10 to the power of 12 number of records, which comes up at about a few hundred terabyte data sets. There are not that many databases out there that can provide that kind of scale. And furthermore, we also want for smaller SPs that don't have a full site reliability engineer department to be able to support this. We want to minimize the overhead to SPs. The data store must be easy to operate within small teams. Also, it should be open source and horizontally scalable. So we have evaluated a few different data stores that could fit this description, namely FoundationDB, Postgres, Yugabyte, and Cassandra. I'm not going to go over all of them right now, but ultimately we picked YugaByteDB, and you can find the benchmarks that we ran on the URL on the slides. So why YugaByteDB? Basically, Yugabyte and Postgres performed the best out of those listed in the previous slide. And Yugabyte was a lot faster than Postgres. Over 24 hours, we were ingesting indices for more than 2 petabytes of raw data during the benchmarking phase. Given the amount of data that SPs are holding today, that's basically a good result, meaning that they can run a migration within a single day and convert all the indices that they hold into their existing DAX store into the new system. The latency for concurrency lookups was also quite good, between 1 to 5 millisecond range. And YugaByteDB is very easy to operate in small DevOps teams compared to Postgres. So Postgres has a number of node types, whereas YugaByteDB has a single node type. Ultimately, it's easier from an operational perspective to maintain YugaByteDB as well as scale it up and down, add more machines if you scale your operation, etc. Basically, the results that we got during the benchmark phase are in line with other public benchmarks, and you can find a lot of them on the Yugabyte website and other public resources. So how does Boost store those indices? The storage client sends already prepared data to the storage provider, And then Boost receives this data, compares the Merkle tree hash, and assuming that it's correct, it begins indexing the data. And then the index data is what gets stored in the local index directory. The raw data gets passed on to the ceiling subsystem, which generally is the Lotus miner. And that's how data gets onboarded. Later on, if you're trying to retrieve this data and you request a CID, even if that's an intermediate CID within the 32 gig sector, the storage provider can find it within the index and serve it back for retrieval. So the local index directory interface, as I mentioned, is backed by YugaByteDB. And the interface fits on a single screen, which means that large SPs can implement any database that they're comfortable with. Obviously, small SPs that have engineering teams of few engineers don't have the capacity to build that, so we provide two adapters, the YugaByteDB one and the LevelDB as well, for smaller operations. But if you are a big SP and you have larger engineering teams, it's not easy to build a new adapter and support the database of your choice if you don't want to use YugaByteDB for a certain reason. Another feature that we built in Boost v2 is support for a shared local index directory. This means that if you are a larger SP organization that provides infrastructure to multiple other SPs, you can literally have a single index data store that holds the data for multiple miner IDs. So if you're running multiple miner IDs, they can all connect with the same to their respective Boost D, Booster HTTP, and Booster BitSwap instances. So you can provide data from one SP that's stored on a different miner ID. And the same way storage dues are handled with the respective storage provider, but all the indices are stored within shared local index directory. So that makes it very easy for organizations that hold multiple miner IDs to basically have common infrastructure and fewer processes to look after. Last but not least, I want to cover the protocol rewards and the way we think about data integrity in the Boost team. So as everyone here knows, there are no protocol rewards for retrievals. I mean, Filecoin only has the block rewards as protocol incentive. So if the local index directory or YugaByte is unavailable, obviously retrieval functionality is not going to be available. All retrievals are going to fail, but the SP will continue to receive block rewards. So if you want to have confidence from an SP that they're going to provide retrievals to you, you need to sign SLA agreements with them or have some kind of off-band agreements. This is not going to get covered by the protocol at this stage. Because of that, in terms of how much you should be backing up or how many replications you should have for the index database is up to SPs to decide. We get asked a lot, for example, in what configurations SPs should run their YugaByteDB instance, and this really depends on the SLA with clients. So in case of disaster, SPs must ensure integrity over their sealed sector files because those get periodically challenged, and you must submit window posts to the network. And additionally, of course, the repository contents, such as Lotus Miner path or Boost path, also known as the Lotus Miner repository and the Boost repository. Those must be regularly backed up because obviously if you lose your sealed sectors, you're gonna get penalized by the network. Looking at the indices, SPs can reindex all of their data, assuming that they keep the unsealed sector files. So if you lose your YugaByteDB for one reason or another, you can recreate all the data that it holds, assuming that you have the unsealed sector files. So we don't consider it as critical data at this stage. And that's all I have for you today. Thank you.